Record. Chapter 2. Chapter 2 looks at some chemistry stuff. Obviously, phys is a buttload of chemistry, so hopefully you remember some of this. Okay. I hope to all of the gods in all of the places that you remember all of this, to be honest. Okay. But we have a number of various different elements that we'll be looking at. Okay. With these various different elements, and we're going to be looking at, hydrogen ions and sodium ions, potassium ions, chloride ions. All right, we're going to be looking at predominantly those. Understanding a little bit about how they react with things, how many electrons they have. I mean, all that's fantabulous, and hopefully you remember it. Okay. Because especially when it comes to cellular respiration and metabolism, I mean, we're going to be talking about electrons moving from this location to the next location, harnessing them for the good of making ATP, making power, right? So I'm just hopeful that you remember kind of what these things are and where these electrons are found floating around in what are called orbits. Okay. All of these dudes right here are little bitty electrons. What does an element, what do these things like to have electron number wise in their outermost shell to be at equilibrium?
8.
8. Fabulous. What rule do we call that rule?
Yeah.
The octet rule.
Yeah, boys and girls. Octet rule. OCTET. Whoops. Octet rule. Awesome. We'd love to have 8 electrons. If there's one there, just floating around in the shell, booyah, get rid of it. Or it likes to go find something and hook up with. If it's missing one, it's going to go find something. All right. So it's these little bitty electrons that we pass around there. There you go. In those little orbits. Okay. That it loves to fill. Remember, the first shell always holds 2 electrons. Every shell after that holds 8. Okay. Just some universal constants that you should probably know. And you all remember that one. I'm not going to ask atomic numbers. I'm not gonna, how many bonds can hydrogen do? It loves to bind 1. It has 1 open space, okay, because it has only 1 electron. It's the only one with 1 electron in its first shell, okay. Carbon has 4 electrons in that outer shell, so it likes to bind with up to 4 things. Nitrogen can form 3 bonds, oxygen 2, obviously, sulfur 2. So, I mean, of these, I didn't mean to circle that one. Okay, carbon, nitrogen, oxygen, hydrogen, these are going to be things that we're going to be, seeing and talking about with, obviously, some chemistry going on and happening with how these processes are happening. So this is the basic understanding of why these things can bind with that, or bind with that number of things, okay? Isotopes, same element, just a different number of neutrons. Isotopes are fabulous for imaging studies. Having something radioactive isotope, you can have them chug that bottle of dye has a radioactive isotope in it. And you can look at a person's innards and you can see a whole bunch of stuff. So that's what isotopes are. Chemical bonds. Close your eyes. Question. Covalent bond. Do they share or do they take?
Share.
Beautiful.
Share.
You got it. Everybody is a winner today. Ionic, obviously, one takes from another. Okay. So we have covalent bonds. We have ionic bonds. Is there another major type of bond that we have, or slightly major?
Hydrogen bonds.
Hydrogen bonds, right? Hydrogen bonds are weaker, but together
Yeah,
they're
I mean,
stronger, you know. Okay. So yeah, covalent bonds share their electrons. Okay. It can be equal sharing, it can be unequal sharing, right? If it's equal sharing, there you go. If it's unequal sharing, there you go. There's unequal sharing. Okay. Sorry, hit the wrong button. There's some equal sharing right there. Methane, ammonia. Water has some unequal sharing. You have polar and nonpolar covalent bonds. Hopefully, I'm sure you all remember that. Water has some polarity to it because it does not share its electrons equally. And because of this, we can have those. I don't know why my thing keeps doing that. Right? Or I'm sorry. And those little dashes there, that's my interpretation of those hydrogen bonds, right? And that's what gives water all its fabulous, fantastic properties, right? Able to have a high heat of vaporization, high rate of absorption, high heat of absorption, adhesion, cohesion, all that fun stuff. And, you know, those are some basic concepts when it comes to really forming some of the functionality of blood and understanding how blood is going to be moving through tubes and whatnot, as we talk about later on in the semester after break. Ionic bonds, one takes away. Okay. So this is where we're going to have positive and negative ions. Those are cations and anions, respectively. And again, we'll start talking about this when we start talking into the next unit, when we start talking about ions and sodium ions, positive and negative ions associated with helping to maintain resting membrane potential when it comes to nervous impulse conduction, skeletal muscle contraction, all that fun stuff. Okay. NaCl obviously is the classic example, and there you go. Sodium only has one little electron floating in that outer expanse there, and obviously it loves to give it up. Chloride loves to take it. It needs one more to have the octet rule, and ta-da, I have salt. Here's another little rendition of it. Yeah, I mean, where do we find ions? Find ions in water. Water is the medium for which these things are going to be delivered. Water is the medium for which these things are going to help to be broken down. Okay. Obviously, water is a byproduct in cellular respiration, in metabolism. So water is going to be an important concept when it comes to helping to get chemical reactions to be facilitated, right? I mean, obviously, enzymes help to facilitate chemical reactions, but we have hydrolysis reactions, right? That break down big things into smaller things. So water is going to be a medium through which we're going to see a lot of chemical reactions occurring, especially when we get into the blood, helping to regulate acidity of the stomach, all sorts of fun, fantastic things that we're going to talk about. There we go. There's Mr. Hydrogen. Weak bond. Yeah, I mean, adhesion, cohesion, that's one of the properties that has a high surface tension because of adhesion and cohesion. Holds DNA together, which is a biomolecule that we'll briefly talk about here. Again, there's a better rendition. I guess, than my artistically drawn hydrogen bonds.